okay, here's a summary of what I was talking about. So if you add an isotonic sodium chloride to the body, all that's going to happen is your extracellular fluid is going to increase. If you add a hypotonic sodium chloride solution to your body, three things are going to happen. First of all, the osmolarity is going to decrease. So you're going to become less salty, basically. There's going to be less solute in your body. Your intracellular fluid is going to increase, so good for hydration. And your extracellular fluid is also going to increase. If you add a hypertonic sodium chloride solution, three things are going to happen. Your intracellular fluid is going to decrease. So again, that's useful for treating edema. Your extracellular fluid is going to increase because it pulls water out of the cells, because it's saltier outside of the cell than inside of the cell. And then the osmolarity of both, just osmolarity of your body is going to increase because there's going to be more salt in your body because it's a hypertonic solution. It is more, which is what hyper means. Hypertonic, it's more salty, basically. So, here's some clinical abnormalities associated with this. Hyponatremia. Hyponatremia. That is not enough sodium, basically. You're losing sodium chloride, or just sodium in general. Can happen due to too much sweating, diarrhea or vomiting, too much use of diuretics, which means you're peeing too much. Too much coffee, too much alcohol can cause that. And it can also happen as a result of aldosterone secretion, which is, you have a lack of that, and that's what Addison's disease is. You can also get hyponatremia when you drink too much water. That's how that woman died. Hold your pee for a wee, right? She was trying to get that wee. She tried to win the competition by drinking 2 gallons of water in like a minute. Ridiculous, right? But she won, but she paid the ultimate price later by dying. So, because her brain cells exploded. So you don't want to be too hyponatremic. You need to have some salt and some water. Just my advice is drink water until your pee is clear, or not orange, right? Or not dark yellow. That's probably a good idea. Drink water until your pee is straw colored, or almost clear. That's the healthy way to be. Okay. Hypernatremia is water loss intracellularly. Okay, because you have too much salt in your body. So what happens is, this can happen during heavy exercise. You get a negative fluid balance. It can also happen as a result of a lack of antidiuretic hormone response in tubular cells. That's what diabetes insipidus is. Hey Swaroop, how are you doing? It's good to see you again. Excessive sodium chloride is also a cause of hypernatremia. And that can happen due to oversecretion of aldosterone. It can also happen as a result of an increased dietary intake. You just eat too much salt. you know. And that's all for the first lecture that I had for physiology and histology. Now we're going to talk about histology, focus on histology. So we're going to talk about the urinary anatomy, the kidney structure, gross structure, which means visible to the eye, cellular structure, and the function of everything. So you have a kidney, you got the ureter, the urinary bladder, urethra. The kidney's job is to promote homeostasis. Hey Carson, how are you doing? Homeostasis is the tendency toward a relatively stable equilibrium between interdependent elements. I'm your favorite YouTuber. Well, thank you. Get liked? Well, thank you. I appreciate that. Anyway, the kidney removes waste, right? It removes waste from the blood, metabolic waste products. It regulates blood electrolytes. It regulates fluid volume and blood pressure. And it regulates blood acid base. Okay, so if your blood's too acidic or too basic, your kidney helps that. Swaroop, of course I remember you. Yeah, you were on my streams a couple days ago. Hey, Dr. Bibiton. How are you doing? The kidney also works in secretion of bioactive molecules like renin or erythropoietin. Erythropoietin is a kidney hormone bioactive molecule that basically makes your body raise the red blood cell count. It's usually in a response to a lack of oxygen. And so more red blood cells equals more oxygen if you're in a low oxygen area. I got sick like 4 weeks ago and I still am. I'm hurt. I'm sorry to hear that, Hunter. Oh my goodness, you almost died. Well, I hope you're doing better now. Oh well, you said you're still sick. I hope you're doing better than you were. Yeah. Anyway, what was I saying? So, erythropoietin. If you were to climb Mount Everest and get near the top, I'm not going to be live for much longer, Swaroop, because I've got to go to school very shortly, actually. Starts at 8 a.m. and it's 7:13 a.m. So, but I'll be on for a little bit longer. If you climb Mount Everest, your kidneys are likely to secrete erythropoietin because you need those red blood cells, because there's not a lot of oxygen up there. The air is very thin, right? And so you're going to have trouble breathing. But if you're up there for a while, you know, your body's going to adapt. You're in the gym, Swaroop? That's awesome. What are you working out today? Hey, Frederick. Good to see you again. Alright, so the arcuate vessels, the medullary rays, and the ureter of the kidney, very important structures. The hilus is the concave depression in the kidney. That's where the arteries, veins, nerves, and lymphatics enter in and exit out of the kidney. The ureter transports, or ureter, however you want to say it, transports urine to the bladder. And then there are some things called the renal sinus, and then the hilus, and then the renal pelvis. The renal pelvis is where the urine collects in the kidney. The calyx is where the urine comes out of the kidney, basically. And then there's the renal papilla, or renal papillae. They are literally, like, that's the spot where the urine leaks out of where the urine is made in the cortex and medulla in the kidney. Pretty sure it's made in the medulla. Not too sure though. Human, pig, and cattle kidneys are multilobular, which means they've got multiple lobes, right? And the kidneys of carnivores, horses, and small ruminants are unilobular. So unilobular, one lobe, right? They don't have any calyces. And a calyx is, I don't really know what a calyx is. Anyway. Hey, Exonin, I hope I said your name right. Kidneys become pale with low erythropoietin, which can result from kidney failure. It can happen due to kidney failure. And what that does is, low erythropoietin causes anemia because your body's not making red blood cells. And that's what anemia is. It's a lower red blood cell count. So, lots of, there's many diseases and bacterias and stuff that can affect your kidneys. For example, petechiae can form, which are like small hemorrhage sites all over the mucous membranes of the whole body. But if you pull out a kidney of an affected animal, I wish I could show this picture, but it's copyrighted. But man, this is nasty. So, yeah, this dog had a systemic acanthamoeba infection, some acanthamoeba species. Exonin, I am just talking, I'm just talking to y'all, and then I'm also talking about what I'm learning in vet school, and I'm also studying what I'm learning in vet school by talking about it. Thank you, Frederick. I appreciate that. The area cribrosa is even more zoomed in of the renal papillae or renal papilla where urine comes out. These are the holes, right? This is where the urine comes out. Urine is produced in uriniferous tubules. So you may have heard of seminiferous or seminiferous tubules, where, semen is produced in the testicle. But in uriniferous tubules, this is where urine is produced in the kidney, right? And so the cortical radial artery is the term used in human medicine, but in veterinary medicine, it's interchangeable with the interlobular arteries. Same thing, just called different, or called differently. So, oh my goodness, there's a lot here. How much more of this do I have? Oh, a lot more. Okay, so uriniferous tubules, they produce the urine. There's about 2 to 3 million per kidney. Thank you, Exonin. I appreciate that. Frederick, you're playing VR. That's cool. That's awesome. The uriniferous tubules begin in the cortex, though. Basically, they produce the urine, but they begin in the cortex, they send their loop into the medulla, they return to the cortex, then they drain into the collecting tubules, and then into the collecting ducts, and then into the area cribrosa, where, you know, that's where the urine leaks out into the renal pelvis, right? And the renal pelvis that's the collecting duct, I guess, that collects and shoots it toward the ureter, which shoots it toward the bladder, which shoots it through the urethra. It's a little bit more complex than this, but you get the drift. So, the nephron and the collecting tubule system are all a part of the uriniferous tubule. There's the collecting tubule, the collecting duct. Those are part of the collecting tubule system. And blood flows from the afferent arteriole to the tuft of capillaries and to the efferent arteriole. Excuse me, in the uriniferous tubule. Okay, so there's something called the Bowman's capsule. It has the Bowman's space, the visceral epithelium, and it has parietal epithelium. All right, Frederick, see you later. It also has mesangial cells. I can't remember. Well, this was histology. This wasn't physiology, so they didn't really talk about what all these things did. They just talked about what they looked like. So, capillaries are made up of a single layer of epithelium. And visceral epithelium, mesangial cells, endothelial cells. These are the only expected cells to be seen in a section of a kidney. If you see any other cells, see you later, guys. Or see you later, Frederick. Then it's probably not a good thing. It's probably like cancer or something. It's not a good thing. Then there's things called podocytes, which are, foot processes. Podo means foot. These are another cell you can find in the kidney. Endothelial cells are going to have a bulging nucleus kind of thing. Mesangial cells are found in the interstitium of the glomerulus or glomerulus. They are phagocytic, which means they operate in turnover of glomerular basement, or they turn over the cells in the glomerular basement membrane. It's similar to smooth muscle, the tone of which can control blood flow through the glomerulus. So these are, good to have. Only a couple more to go here. The renal corpuscle or corpuscle is composed of glomerular capillaries, mesangial cells, and the Bowman's capsule. And remember, the Bowman's capsule is composed of visceral epipodocytes, parietal epithelium, visceral epithelium, which has podocytes, parietal epithelium, and then the Bowman's space. All of that that's basically, if someone says renal corpuscle or corpuscle, they're referring to all of that. Glomerular capillaries, mesangial cells, Bowman's capsule. Okay. So that's pretty much it. That's all I can really do for right now. I got to go to school, but thank you all for watching. I will see you later. I'm going to finish this up later. And yeah, thanks for watching.